Welcome to this video for Danish. This is, let's have a look. This is 2018. 2018. This is the March paper. Interesting. We don't see much of those. And it's question paper 42, and it's question 3, part C. Okay, an aqueous solution of potassium cyanide is gradually added to a solution of nickel sulfate until the KCN is in excess. The following reactions take place: that, and that. We get a precipitate here. So what can we assume from that? If you remember, when we did this in class, when we used what did we use? Copper sulfate. We used copper, didn't we? It precipitated out when we got a neutral thing. Okay, so I'm going to guess this is neutral. Okay, it goes back into solution, so this is charged again, and this is charged. Okay. All right, now if you're wondering what I'm talking about, if you remember when you have copper in solution, it reacts with 2 hydroxide ions and it precipitates out. And why does it precipitate out? Well, because it doesn't have any ion dipole charges with the water. The ion dipole with the water are they no longer exist now because this is not charged, and that's why this precipitates out. Okay, so I'm going to assume something very similar happens here with this guy. So let's get rid of that rubbish. All right, so what do we start off with? We need nickel sulfate. Now, nickel, as you know, looks like this, and these are all waters. So let me build my waters around it. H2O, 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 and H2O. Obviously, this is an oops, that's not good, is it? This is an octahedral thing, and these are coming at us, and these are going back into the board, or back into the page, or the computer in this case. All right, so this is this. There you go. Sulfate, I couldn't care less about. It doesn't say anything contains sulfur, so we're just looking at the nickel ion. Now we add KCN, and how many KCNs or how many CNs are going to give me something neutral? Well, it says here the charge doesn't change on well, it says it somewhere. Where does it say that? The oxidation state of the nickel does not change. So initially, the nickel is, obviously, it's Ni2+, because this is the formula of the sulfate. So how many CNs do we need to make this neutral? We need 2. Okay, so let's draw this a bit nicer. Okay, there's my whatever you call that. There's my nickel. I'm going to water there, and there. Okay, I'm going to leave those 2 for now, and I'm going to put water there, and I'm going to pretend, well, I'm going to guess that 2 CNs come on. So even though the charge on the nickel is 2+, these are minus minus. So this is a neutral compound, and I'm going to guess this is my green precipitate. Okay, so what's the formula of this? Well, it must be, where are we? It's Ni. You could do this, couldn't you? You could say H2O 4 times, Cn twice. Okay, for that. Or you could leave out the waters and you could say nickel cyanide, like that. Okay, NiCN2. All right, just like we would say for copper, CuOH twice, and this is a blue precipitate, and this apparently is a green precipitate. So I hope that makes sense. This is my guess for the green precipitate. Now I keep on adding more KCN, and I get a yellow solution. So, and now I've got a ratio of 1 potassium. So we have, 2 potassiums. So we have 2 Ks. Okay, and the other thing must be have a charge of 2 minus. Now this is neutral, isn't it? So how do I get this to have a charge of 2 minus? I get rid of these, get rid of that one, and put 2 more CNs on. There's another CN, and there's another CN. Okay, let me put my little dashes there. So the formula of this compound is this guy here, all right, which is NiH2O twice, Cn 4 times, yeah, and 2K. So if I wanted to do the full compound, it's K2 NiH2O twice, Cn4. Now I don't know whether they're going to add the waters or let me keep the waters in, but this would be the 2-to-1 ratio. Okay, so I'm going to guess that this is my answer here. So I'm going to say K2. I'm going to look at the answers, don't worry, and make sure. And I'll leave this up, even though I might get it wrong, because it's good that you see me get things wrong. Okay, so I'm going to guess that's this one, D. All right. Now E, well, it's 3-1, so I obviously have to add one more Cn, don't I? So imagine that's gone there, and we add another Cn, and that makes this thing, this complex, the whole charge of it -3. And if that's -3, I'm going to need 3 potassiums, aren't I? So that's all it means. So it's going to be K3, Ni, H2O. Now it's going to be H2O1, Cn 5 times. Okay, there you go. That's what my guess would be. Now let me have a look at the answers. I hope I've got the answers somewhere. Where are they? Actually, it doesn't look as though I do. So let me pause this and dig around for the answers somewhere. Right, 1 second. Okay, so I've managed to dig up the answers. So we definitely, here we are, where's my pen? We definitely get this one. So we get the mark for C. Thank God. We've already got C. Now, would they accept D? And would they accept E? This is D and this is E. Now, what the difference here is, I've got exactly the right answer, haven't I? CN4 and CN5. The only thing is I've included the water. Okay, and there. Now, which one is right then? Would they accept my answer? I've looked at the examiner's report and it doesn't say, I must admit, it doesn't say. But you know what? I cannot see why my answer is wrong. Okay, because these imply the H2O acting as ligands. Okay, because this is a complex. The cyanide, the nickel bit, where are we? This bit is a complex, and this bit there's been ligand exchange, and then with the water to form that one. So I cannot see why my answer could possibly be wrong. Okay, I'm not doing this out of pride or anything. I'm doing this out of, I honestly don't think that they could mark my effort wrong here. I think this is right, honestly. Now, this brings us an interesting question. Do we look at the answers and complain and think, oh my God, we didn't get that? Or do we go? What do we do? We do what we think is right. I honestly think you should never follow the answer schemes. If you chase answer schemes, you'll go mad. Do what you think is right, and I honestly think this is right. Okay, I have no reason to suspect that they would say the ligands, including the water ligands, the neutral ligands, would be wrong. Okay, so I think I've done it right. Honestly, if you want to argue, that's absolutely fine. But I think this is fine. Okay, I hope that makes sense, and I'll post this now.